Hi guys, I just wanted to go through a quick update on this DIY CNC machine that I'm working on. Might not look like a lot has happened to the machine physically, but what I have done is I've tested it now. I've got some videos of that to show you. I've got some products that are the results of using it, and it works. So like I mentioned in the last video, I updated upgraded these stepper drivers, stepper motors, both actually, and I also upgraded the power supply to it. The reason I upgraded the power supply is because I was running 12 volts, 8.5 amps, which is more than enough for a system of this nature. But this DC spindle that we've got here, this DC motor, is 24 volts, and what I was using to compensate for that and have it all run the same sort of power supply is this buck converter booster. Now yeah, it works and it was fine, but I just decided to upgrade it, the power supply, so I'll get rid of this really, and that's what I did. Just quickly show you, don't know how good this will show, but this is the new power supply. We've got 24 volts, I think 15 amps, but 100% overkill for this. I also upgraded the drivers for this. I didn't like the stock ones that came with this. I put a little blower in there. Now, ideally I'd like to put all of this in a little container, if possible. Maybe 3D print something for it, or maybe 3D print something to house all of that. So it's all in there, cooled. Now, a few things that I noticed with the spindle there was a little bit of vibration, as expected, when I was running it. Especially, I couldn't run this at 24 volts. I had to run it at 20, because otherwise the 24 volts it was just too much vibration. You can really notice that on the piece that it was milling. So it wasn't working really well, really. Thing that I noticed while I was using it, there seemed to be a lot of rattle. Now I know that this is my prototype, so I expected that, but I just couldn't find out where the rattle was coming from, to be honest, because I've taken some decisions here to do things in certain ways. For example, on these brass nuts here, I'm not using bolts. I've just glued that in with some epoxy. That works perfect, not a problem. So I think it's these threads, these bearings I've put in here. Once they start to get the lubricant result, because I lubricated this before it was running. Now it's just nothing there. So as it runs, and just you got the sawdust landing on here and scraping off this, and then this moves up and down, it just takes it off, and then sawdust falls off, and it's just basically cleaning it. But then the bearings inside, the ball bearings just dry out and there's no lubricant inside of it. So the rattle noise just gets louder and louder as you go, as you might be able to tell from the snippets that I'm showing you. But apart from that, it worked fine. There was no problems. I think one of the main problems with these types of machines that use an Arduino shield or something of that nature is not necessarily with the sort of the CNC movement, but it's got to do more with the spindle itself and how you control that spindle. Because yeah, you can turn it on, etc, etc, but to control something like this, 24 volts, this is 24 volts 3 amps with an Arduino or an Arduino shield, it's not something that's quite easy to do, and it'll need other components. Now, one of the ways I tried to work my way around was I did this quick PWM controller. It was just very straightforward. I used a 555 IC timer on their common schematic. Pretty straightforward, and I controlled it like that. But yeah, for the time that this has to run, this just gets too hot, and it just overheats in the 5 timer just blows, and the MOSFETs just go. I also tried putting in some fans there. I thought about some blower fans and things like that, but I just didn't think that. It's not a matter of thinking. It's just it didn't work really. It just was too much current running through it. It just wasn't enough. Maybe if you want to see more details on that, just let me know. But I think what I'll end up doing is using 3 MOSFETs and driving them all through that, so I can sort of partially divide the current through the load and control a bit better. But yeah, because otherwise, it's just so difficult to do and to control that, especially when you're using things like easel, that's asking you what RPM you're running your motor at, but you can't really tell what RPM you're running at. It's more of a trial and error procedure where you have to just tune it and do a few test runs, which is what I had to do. I had to do a few test runs to see what was best, what the best parameters for it. Another thing that I noticed was that this, because the surface, it's 3D printed, it's not going to be perfect. There was some sort of irregularities with the level, and what ended up happening was at some points when I drilled the piece in place, at some points it was a lot deeper, but I think that's one of those things that the machine needs to sort itself out, where as in terms of you have your surface and then you'll just have to sort of plane it all with the machine itself, but I didn't get around to do that because this is just a prototype. And just the last thing I'd like to mention, which I previously touched upon, was these rails. I've got all this in now, and I've sort of placed the bed and everything. Now, I don't think I'll lose a lot of space by doing that, by using this method, because the amount of the bed can move would be limited. So right now I've got about 350 by 350 work area. By using this I'll end up with 350 by something like 200. But I'll gain a lot of stability, and I think when you use these sort of methods, I think it's a more durable, and I think it'll take a heavier load in terms of what it can mill and what it can't. That's why you usually see these sort of in milling machines rather than CNCs. Well, rather than this type of sort of CNC. So it might be something that I'll look into later on, and I'll see. But moving forward with it, I think I'd like to now just move on to revision 2 of this. And before I do that, I'm going to tidy up all these cables. I'm going to create a PWM controller. If you want to see some of that content, just let me know. And as well as that, I'm going to tidy up all of these cables because it's just very messy. And then I might 3D print this again because I did crack down there, but that was due to something else. I think my tolerance was too low when it came to putting the bearing in. So I just forced it in a bit too aggressively and it just cracked. But that was fine, so it works. And then this here again, as you can see, because I wanted to get the full Z height, I just put these M3 bolts through there with some nuts. Yeah, I think I'll just 3D print that again. Well, all of it, and just fix that. And then again, I might 3D print this part again here. Because when I did it, I didn't place the holes in for the stepper motors. So that was one of the things that I needed to regardless. But overall, really happy with it. It worked really well. But there are some things to fix. But I think for what it is now, I'm going to leave it, upgrade those parts that I've mentioned, and I'm going to move on to potentially making this out of extruded aluminum, making it a lot bigger, and sort of getting rid of these. Now, as most people will know, doing it like this in this way, where you have the lead screws and lead rods, is the cheapest way you can do it in CNC machine. Using extruded aluminum becomes extremely expensive. because it's not the extruded aluminum itself, but it's the additional hardware that you need, all the belts, all the bearings, and then you need the plates. So then it just starts to adding up. But I just wanted to make you aware of that if anybody wants to go ahead and try making one of these machines. This is the most affordable way of doing it. But yeah, so next step is I'm gonna try and make an extruded aluminum. I think I'll make it about something like 1200 by a meter wide. Yeah, and I think that's the size I'm gonna make it. And I'm gonna make it. I'll make everything open source. If anybody wants access to it, just email me. And I'll send you all the files. But like I said, you know, you'll have to play with your own individual 3D printer to make sure about tolerances and make sure everything fits. And I'll fix some of the issues that I've got here. But yeah, thanks for watching.